Okay, well today we're going to be talking about Chapter 5-6, Parallel and Perpendicular Lines. And our parallel and perpendicular line objective for today is to determine whether lines are parallel, perpendicular, or neither, and then also to write equations that are parallel and perpendicular. Okay, so our standards is A1.2.2 and A1.2.3. Okay, so parallel lines, they're two lines that are parallel, have the same slope. Okay, so if we are parallel, we're running side by side, we're always going up and over. Run over, or rise over run would be exactly the same. Okay, so in other words, we can write this as m1, which is the slope of our first equation, is equivalent to our slope of our second equation. Okay, so however, they must have different y-intercepts, which means B1 absolutely cannot equal B2. Okay, so if their slopes are the same and they have the same y-intercept, they're actually going to be the exact same line, which means that they're going to be touching everywhere, not just one spot, every single spot. Okay, so we cannot have the same. So as we talked about pretty much, parallel lines do not cross. They're lines that run side by side but never ever will touch. Okay, so problem 1, write an equation of a parallel line. We have a line that passes through 12,5 and is parallel to the graph of y equals 2/3 x minus 1. Okay, so we start breaking down what we need. Well, we need this point that they provided us. Okay, that's the important part. Now the other stuff is really not that important besides one little piece. Okay, we look at this equation and we knew that it was parallel. So all we need is the slope, just the 2/3. That's all we need. Nothing else from that equation do we care about. Okay, so what we have is that we can say m1 slope was 2/3. Well, since m1 and m2 to be parallel have to be the same, we now know the slope of m2. After that, we have a point and we have a slope. So the question becomes, well, what do we want to use? Well, in this case, we want to use point-slope form because you have a point and you have the slope. So we're going to say y minus 5 is equal to 2/3 x minus 12. So that's just plugging in the point-slope form. And now we're just going to distribute the 2/3 because they did ask for it to be in slope-intercept form. We're going to get 2/3 x, which is your mx. And then 2/3 times 12 is going to be 2 times 12, 24 divided by 3 is 8. And then we get y minus 5. We're going to add 5 to both sides. Okay, remember, what we do to one side, we must do to the other. Alright, so we add 5 this side, we have to add 5 over there. We get y equals 2/3 x, and then it's minus 3. And so you'll notice from this equation up here, 2/3 is still the slope down here. However, they have different y-intercepts, which means they're crossing on different points on the y-axis, but then they're rising the same amount. Okay, so that does confirm that we are parallel. Okay, so example 2, you have a line that passes through 215 and is parallel to the graph of y equals 4x minus 1. Now I want you to do that on your own, see how you get that, and we'll check that followed by a pre-quiz, and we'll check that tomorrow in class, see if you got the same answer. Okay, we're going to go ahead and stop right there. We'll come back in the next video and talk about perpendicular lines.